Hope everyone is doing well. It's your teacher, Mr. Loon. Welcome to Global Tuition Center. Remember, when your mind is enlightened, your future is bright. It's another day which we have to do with chemistry, which is specifically Form 1. So it's for Form 1. This video is specifically for those who are in Form 1. So there's a question, there's a part in chemistry, which is just the last part, which is term 3, which is Form 1, which has to do with what we call the nuclear notation. So when you see the term nuclear notation, it simply means how an atom, or specifically an element, is being represented on the periodic table. So an element on the periodic table is represented in this format. You discover that this one, just a representation, don't forget that the term nuclear notation just simply means how something is being represented. So specifically, we're speaking of an element or atom. So on top there's what we call the mass number. Then down there's what we call proton number. Then the X there is represented as an element, the name or the symbol of an element. So this is what we call the symbol of an element. So this one represents the symbol of an element. Then this is the mass number of this element. Then this one is the proton number of this element. Now let's try to understand these parts. Now for us to understand mass number, also the proton number, we need to start from this part, what we call the neutron first. So the neutron number. Now what is this neutron number? So neutron number is the number you get, when you subtract. So it's the number you get when you subtract proton number from mass number. So speaking of neutron number, you can see here it's not indicated. So we want to know this one. So if you know this one, it will be easy for us to understand the one on top there. So in other words, they are saying for you to find the neutron, for us to find the neutron number, we're supposed to say the mass number minus what we call the proton number. So it's this one minus this one. Let me just give an example, a lovely example, then I define this one. So let's see the simple example. Assuming that oxygen on the periodic table, when you go on the periodic table, specifically on the periodic table, you discover that oxygen, it has 16 on top, then there's a symbol for oxygen, which is O, then down here, there's 8. So remember, I said the number on top represents the mass number, then here, this number represents what we call the proton number. So if you want to find the neutron, so the neutron number there, so the neutron number will be the number on top there, which is 16 minus 8. And the answer you're getting is 8 there. Now let's go back. Now we see what is the definition of this mass number. Now from whatever we have solved there, so since we said for us to find this one, we need to do this one minus this one. The answer we're getting is what we call the neutron number. But now when you see there, let's see. So when you see there is this is our neutron number. This is our neutron number. Then this is our proton number. So when you get this one plus this one, you get that one. So the addition of proton plus neutron number, you get what we call the mass number. So in other words, we know that now the mass number is the total number of proton and neutron. So the addition of these two numbers makes what we call the mass number. Then this proton number represents also the number of electrons. That's just for further clarity. You need to know that mass number, it has also other names such as atomic mass, also what we call nucleon, not neutron but nucleon. It's written as nucleon, like this, nucleon number, and also known as what? Atomic mass. So this is all but I'll take time to add more videos which relates to Form 1. As for now, I'll simply say thank you.